Okay, so today we're going to be looking at how to work out acceleration problems. The first thing that we need to know when we're looking at acceleration problems is what is the formula for acceleration. And so in our notes, we should have learned that the formula for acceleration is acceleration equals final velocity minus initial velocity divided by time. And so your final velocity is your ending speed. Your initial velocity is your starting speed. And then time is kind of self-explanatory, and that is just the time that it took to get from one speed to another. So for this activity, I've got 3 examples that I'm going to work through, and then I'm going to also attach some videos of some more examples. That way you can see many different examples of how to work out these problems. So the first thing that we want to always do is to write out our formula every single time. That way we remember it. And so acceleration equals final velocity minus initial velocity over time. And so example number 1 says a ball rolls down a ramp. Starting from rest, after 2 seconds, its velocity is 6 meters per second. What is the acceleration of the ball? We need 3 pieces of information to find acceleration. We need the final velocity, the initial velocity, and the time. So as I'm reading through here, it says it started from rest. So rest would be the initial velocity. 2 seconds, that will be time. And its ending velocity or final velocity is 6 meters per second. So those 3 pieces of information will help us to solve this problem. So now I need to go through and plug in my numbers. Acceleration equals final velocity was 6 meters per second. And I know that because that's the second speed it talks about. And it says it started from rest and then it sped up to 6 meters per second. So I have to think about in this problem what is going on so that I know which speed is where it started, which speed is where it ended. So final velocity was 6 meters per second. It said it started from rest. The number for that would be 0 meters per second. Divided by the time was 2 seconds. Now all we have to do is order of operations to solve this problem. So I have A equals 6 minus 0 over 2. First thing I'm going to do is the subtraction. So A equals 6 minus 0 gives us 6 meters per second divided by 2 seconds. 6 divided by 2 equals 3. And our unit for acceleration is meters per second squared. So the correct answer here would be acceleration equals 3 meters per second squared. Now if you go back and you look at this first slide, you will see that I have an arrow pointing at the down here, the unit, and so I have it set up to where you can just copy and paste that if you don't want to fool with going back and doing the squared to the exponent each time. Okay, so let's look at our next problem. Example number 2. Again, we want to write out our formula every time. A equals final velocity minus initial velocity divided by time. The example number 2 says a car traveling at 10 meters per second starts to decelerate steadily. What does that mean, decelerate? Well, that means it's slowing down. It says it comes to a complete stop in 20 seconds. What is its acceleration? So we have, again, 3 pieces of information we're looking for: final velocity, initial velocity, and time. A car was traveling at 10 meters per second, starts to decelerate. So this is the initial velocity. Comes to a complete stop. That it would be the final velocity, and the time will be 20 seconds. So we have A equals Final velocity was a stop, which would be 0 meters per second minus 10 meters per second divided by time will be 20 seconds. So now I have to do my order of operations. 0 minus 10 is negative 10 divided by 20. And then negative 10 divided by 20 equals negative 0.5. Ran out of room. Equals negative 0.5 meters per second squared. Wait, we have a negative number. Can we have a negative acceleration? The answer is yes. If we have a negative acceleration, that means that we slowed down. And so where this problem says that it decelerated, then that tells us that we should end up getting a negative number. That's one way we can check our work and make sure we set our problem up correctly. Next example. Example number 3. An airplane travels down a runway for 4 seconds with an acceleration of 9 meters per second squared. What is its change in velocity? So this time we're solving for something different. So our formula is acceleration equals final velocity minus initial velocity divided by time. Again, we want to write that out every single time we're starting with these problems. So we know time and we know acceleration, and we are solving for the change in velocity. So we know the acceleration is 9 meters per second squared equals the change in velocity is what we're solving for. So I'm just going to put x up there. We're solving for x and 4 seconds. Now imagine this is not science class, but this is algebra class. What would we do to get x by itself? Well, I would multiply both sides by what I'm dividing by on here would be 4 seconds. So 9 times 4 is 36 meters per second would be the change in velocity.